Okay, you guys make sure your mode's in radian mode. Okay, so we get this graph right here, right? All right. Okay, so let's see. Okay, so to find the period, we need to know how long it is left to right, one cycle of it. What do you think? Well, let's first of all decide, what is one cycle on this? One thing. Okay. I saw your hand movement, so I'm thinking you're thinking that right there, right? Okay, that is one cycle on a tangent function. Okay? How, from left to right, how long is that? Where does it start from and where does it end? Now, keep in mind, this is not -2. Remember, these are pi force, these tick marks. So say that again. Yeah, that's -pi half. This right here, this mark right here is -pi halves. And this mark over here is +pi halves. So how far is it from -pi halves to +pi halves? It's pi units long, right? It's actually a length of pi, because a half a pi and a half a pi make a whole pi, right? All right, so what is the period? The answer to that is it is, and I'm going to make this bigger, you guys. Okay, what is the period? It is pi. Okay? I'm going to erase these. Now, looking at this graph, what is the domain of the graph? Well, you guys, I don't know if you've noticed, but right here at pi halves, there is an asymptote. Right here at 3 pi halves, there's an asymptote. Right here at -pi halves, there's an asymptote. Right here at -3 pi halves is an asymptote. And at those points, it's not defined. The function is not defined. So how would we state the domain? What do you think? How would we state the domain? All reals except for, like say you just said, all reals except odd pi halves. Except odd pi halves. So 1 pi half, 3 pi half, 5 pi half, 7 pi halves, 9 pi halves, those are odd pi halves, because there are asymptotes right here. And remember, a vertical asymptote, when we talk about rational functions, it's an imaginary line or barrier that the graph will never cross. So these are vertical asymptotes. It never cross. I mean, this graph going up right here, it will never. It gets closer and closer to that blue line as it goes up, never touches it, and as it goes down right here, it gets closer and closer, never touches it. It will never actually intersect this blue line. Same with the one right next to it, and this one right here. Okay. They'll get closer and closer to those blue lines, but they'll actually never touch them. So at all those pi halves, odd pi halves, you get that. Okay, the next question, what is the range? What do you think? Jay says all reals. Do you agree with him? What is the range? Okay, yes, all reals. Because it goes up forever and goes down forever. It takes on every y value. Okay, what are the x-intercepts? Well, let's look over here. Where does it cross? Where's the first place it crosses the x-axis? If we marked it on here, I'm going to erase these again. Doesn't it cross right there? At zero? At 0? It crosses right here. Where's that? Yeah, pi. It crosses right here. Where's that? 2 pi. It crosses right here. Where's that? -pi. Okay, what do you think? Is it going to cross at 3 pi? Okay, so it crosses at what? Multiples of pi. So we would say all pi's. So I would just write multiples of pi. Is this music bothering you guys? Huh? Yeah. What does it remind you of, Eric? A sinking ship. Okay. Okay, number 6. What is the y-intercept here? That's the easiest question of all. What is it? 0. Yeah, it crosses. This is the only place it's going to cross the y-axis. That's 0. What was that? Yeah. Okay. And number 7. Where do the asymptotes occur? Same place. Well, same place where it's undefined, right? Where the domain is undefined. So where would that be? Odd multiples of pi halves. Odd multiples. I wonder if this is recording on my, I think it's recording on this. I mean, other than, does the sound have to come over here, or since it's hooked to my computer, is it recording? It has to go to the mic? Okay. All right. Okay. People at home watching this are probably going, I can't hear anything. So I don't know. Okay. We got that? All right. Now, next thing we're going to do is we are going to correct assignment 6-5. If you'll get that out right now. In a review of lesson 6-5, just one problem right here. Y equals 6 sine of theta plus pi thirds plus 2. We're supposed to state the amplitude, the period, the phase shift, and the vertical shift for each function, then graph the function. Okay, so amplitude is easy, right? What is the amplitude, you guys? Also, the vertical shift is easy. What's that? Okay, so the amplitude would be absolute value of the number in front of the sign, right? And the vertical shift would be the number that's added or subtracted to the equation. Period is a little bit different. Period, we're going to have to use that formula, period, P equals 2 pi over K. We happen to know K. What is it? It's what? It's 1. Because there's no number right here in front of theta. So it's 1, right? So period is equal to 2 pi over 1, which is just 2 pi, right? Sorry. What was that? Oh, okay. And the last thing is the phase shift. Phase shift is equal to, we have that formula, phase shift equals C over K. So what is C? What is pi thirds? Actually, it's a negative pi thirds, right? Because remember in the general form it's minus that number, so minus a negative pi thirds, divided by K, which is 1. So it's just negative pi thirds, right? All right, one more. One last problem. Okay, 32, okay. Yeah, we didn't do 32, Easton. Okay. All right. We got it? Ready to correct it? What about 30?
Oh, yeah. I'm done then.
Okay. All right, are we ready?
Yep.
What do you, Kaylani, what's your question?
We're ready.
Okay. All right, let's do this. Everybody trade your papers with someone. Okay, you guys, as we said, today we're going to learn about the graphs of the tangent, cotangent, secant, cosecant. I believe we already did this one, right? Okay, so we're going to move on to the cotangent. So right here, use the same window to graph the cotangent of x. So all you have to do, you should have your window already. What you guys should have is the cotangent of x. Y equals the cotangent of x. Go to your y equals, put in y equals the cotangent of x. Not yet. Okay, so we're going to put in our calculator y equals 1 divided by the tangent of x, because that is, we learned earlier in the year, and we learned that the cotangent of x is equal to 1 over the tangent of x. And since the calculator does not have a cotangent button, that's how we have to put it in. Okay, answer the following questions with your face partner. If you need more help, ask the other partnership. I'm going to pause this while you guys answer these 6 questions. What is the difference between the cotangent function, now that we have it in there, and the tangent function? What's some things that you see that are different? Dylan. Where the other asymptote, where the other one crossed it, it's asymptotes. Yeah. So it's shifted. In other words, it's had a phase shift, hasn't it? Okay. What else? John. It doesn't have a y-intercept, does it? It hasn't. It has a asymptote right there. Okay. Sean. Yes. Remember when we talked about increasing and decreasing functions at the first year, you guys? This function is decreasing as you move left to right. What is each one of these doing? Decreasing, right? The tangent, you guys might want to go back this and put it on your tangent notes. The tangent function is an increasing function. Okay? All right, now, I got to make this a little bit bigger for you to see. I don't think I can make these bigger. Okay? Let's look at, I guess I could take this screen and move it over a little bit, Can I? Because we don't need to see all that stuff right there. Okay, right there. That's what's in our calculator right here. Easton, right there. We graphed it. 1 over the tangent of x. It's decreasing instead of increasing is what we call it. Okay. Let's go through each one of these questions now. Okay. Number 1, what does the period of the cotangent function appear to be? Okay. Does it appear to be 2 pi? What do you think? It's pi like the other. Notice that it only goes from 0 to pi. Okay. So the period is pi. The thing that you guys need to know that's different, the sine and cosine period was what? 2 pi. And the tangent and cotangent period is pi. Got it? All right, now, next thing. Number 2, what is the domain of the cotangent function in the given window? What is the domain? Say that again, Parker. All reals except multiples of pi. That's right. 0, pi, 2 pi, negative 2 pi, and so forth. All reals except for multiples of pi. Okay? Question number 3. What is the range? All real numbers. It goes up forever and down forever, right? All reals. I haven't been writing these answers. Okay. Question number 4. Where are the x-intercepts located? Pi halves. Where else? Where else? 3 pi halves. Where else? Negative pi halves. Where else? Negative 3 pi halves. What's the way we can describe that? Odd multiples of pi halves. Odd multiples of pi halves. Same place where the other things were. What do we call those? The same place where the asymptotes were on the tangent function. All real numbers except for multiples of pi. Okay, number 5. What is the y-intercept? There is none, right? Where are the vertical asymptotes located? Where are the vertical asymptotes located? The same place where the domain is undefined, which is multiples of pi. Got it? Multiples of pi. What was that? Where are the x-intercept located? Odd multiples of pi halves. Odd multiples of pi halves. Got it? You got all this down? Okay. Okay. The domain would be all real numbers except for multiples of pi. Okay, are we ready to move on to the next one? Okay. Now, we're going to do which function is this? The cosecant function. How am I going to put the cosecant function in my calculator? I know you know it, Ramon. Don't say it, because I just heard him say it. I want you guys to think about this for a second. How would I put the cosecant function in your calculator? I want you to tell your shoulder partner when you think you know. Tell me again. You got that? Okay, good. Tell Mikhail. Oh, okay. All right, here we go. So you guys go to your y equals screen right here, and let's put it in. What do you guys all get? Yeah, 1 divided by the sine. Got it? 1 divided by the sine is going to be the cosecant.
Whoa.
That's how you'd put it in your calculator, right? You guys want to know what's cool? You want to know what's cool about the cosecant function? Okay, you guys ready? This is cool. I'm serious. You're not gonna want to miss this. Everybody go to your y equals screen. Everybody go down here on y2 and put in the sine of x and hit graph. I told you it was cool. That is cool, right? Huh? They're just wherever there's a maximum of a sine function, it touches its tangent to, or we say it touches the cosecant function. Wherever there's a minimum, it touches the cosecant function, right? Kind of cool, huh? So you always know if you have the right one in. You can tell by doing that. Okay, now we're going to go through these questions really fast. Yeah, they're mostly the same. What's one period of the cosecant function? Is it pi or 2 pi? Okay. Yeah, should be in radians. You've got the x max at negative 2 pi. It should be positive 2 pi. Okay. Yeah. Look, we put in the sine function. Let's take the sine function back out, you guys, so we don't get confused between the two. Take the sine function back out and just graph the 1 over sine of x, which is the cosecant function. What's the period again? Pi or 2 pi? Why do you say 2 pi, Sean? Yeah, and they're two different things, right? That completes one cycle. It takes both of them because one's going up and one's going down. Okay? So it takes two of them, so the answer to that question is 2 pi. Okay, what is the domain of the cosecant function? Okay, it can't be 0 because there's an asymptote right here at 0. What else? There's an asymptote at 0. Where else is there an asymptote? 2 pi, there's an asymptote right there. Pi, there's an asymptote. Where else? Negative pi. So what's the domain of this thing? All reals except for multiples of pi. What is the range? Ramon's got it. Anybody else got it? Look at you guys. This graph has a no man's land. Right here, you guys, if you go draw a horizontal line at 1 and a horizontal line at -1, this is the no-fly zone right here. Okay? That is the no man's land. There's no part of the graph that exists between -1 and 1, right? So we would say that the range is all reals greater than 1 and all reals less than -1. Instead of putting all reals there, you just say y is greater than 1 and y is less than -1. Okay, it is a compound inequality. You're right. Okay? See, there's no part of the graph that exists between -1 and 1. Didn't I say less than -1? Yeah. All reals less than -1. And all reals greater than +1. Because it only exists from 1 and up, that's greater than 1, and -1 and down, that's less than -1. Got it? Okay, number 4. Where are the x-intercepts located? What do you think? Where are the x-intercepts located? Yeah, there are none, right? None. What is the y-intercept? None. It never crosses. There's an asymptote along the y-axis, so none. Where are the vertical asymptotes located? Multiples of pi. Multiples of pi. We got that? Now, let's see if you guys can answer the last one all by your lonesome. You guys got these down yet, or are we still writing them? I hear you guys. Let's see if you can do the secant function on your own. I'm going to give you 3 minutes. See if you can graph it and answer the 6 questions. Okay, you guys, question. Oh, first of all, how do you put it in your calculator? Y equals what? One over the cosine of x. Okay. Answer question 1. What is the What is this? What is the period? 2 pi. Everybody got that? What is the domain? I guess I should graph it in here, huh? Okay. What is the domain? Okay. All reals. X is not equal to odd multiples of pi halves. Okay, what is the range? What's the range, you guys? Y is greater than 1, or y is less than -1. Remember, there's nothing in between -1 and 1 on the graph as far as the range goes. You know what? It is equal to. Good. Okay. Where are the x-intercepts located? How many x-intercepts does this thing have? None. How many y-intercepts does it have? And where does it occur? At y equals 1. Where are the vertical asymptotes located? Odd multiples of pi halves. Last question. What's the one cool thing about the secant function?
Looks like something off Pokemon.
Yeah, that's right. What Rachel said. Okay? You'll have to ask her again. If you put the cosine function in and graph it, it bounces off the jellyfish, I think she said.
Oh!
Okay? There you go. Does everybody see that? Guess, okay, got it? That's kind of cool, isn't it? How the cosine and sine functions do that on the cosecant and secant functions?
Wait. Can you move?
The question is, can we shift these up and down? And everybody put in the tangent function. And I want you to do this. Put in 2 tangent of x as well. Now, I don't use this one a whole lot, but you need to know what if you multiply a number by the tangent function, you need to know what it does. Let's look at the graph. Here's the tangent function. What does it do? It makes it steeper, doesn't it? Because it's the inside one right here. It makes it a little steeper. Do you guys see that? Okay. If you want to really try, put in something like 8 right here. Put in 8 right there. Now graph it. Okay, notice this one. It almost looks like a line. It's so steep. Do you see that?
Yeah.
Okay. Okay, it just looks like one. It's really not. Okay, now I want you to do this. Put in 0.5 in front of the tangent of x. 0.5 times the tangent of x, and graph that one and see what it does. You guys are missing out over here. What does it do, you guys? Do you see it? Do you see it flattens it out near the 0? Okay, it just flattens it out. All right, last thing. Okay, now I want you guys to know that you can move a tangent function up or down. All you'd have to do is what to move a tangent function up or down? Add or subtract a number. It's a vertical shift. The vertical shift is the same as the sine and cosine function, okay? Now, here's what you guys need to know. Here's what you need to know. You need to know how to find a phase shift. And if the phase shift is the same thing, I can actually, oh, wait, one other thing. Put in a negative tangent of x. What do you think that's going to do? Here's the tangent. What's the negative going to do? Okay, it's opposite, isn't it? Got it? It's decreasing instead of increasing. It flipped it over the y-axis. Okay? All right, next thing I need to show you. Phase shift. Let's go x minus pi force. What, if I minus pi force like this, what's going to happen to the graph? It's going to do what? Shift which way and how far? It's going to shift right pi force, isn't it? Okay? Let's look at that. Here's the tangent function. Here it is shifted pi force to the right. All right, hey you guys, this is your assignment. I'll tell you what, the biorhythms one I'll give you a little time to work on next time. Just bring it next time. Okay? If you turn it in, grab it. I don't want them yet until I get them all.